Greetings, everybody. Learning as a hobby here. I wanted to talk about a new playlist that I'm going to start on the channel, which is on the theory of numbers. So I plan on going through an introduction to the theory of numbers by uh, Ivan Niven, Herbert Zuckerman, and Hugh Montgomery. This is a pretty classic book. This is the fifth edition, which I believe is the most recent edition, which was published, I don't know, maybe in the 80s or something. But this is a very famous number theory book for undergraduates. So I'm going to go through this book on the channel as well. You may be asking, you have so many things on your plate, why are you doing another thing? And that would be a good question. Um, for various reasons, I decided to start it on this, and actually, I'm going to have to add some other things as well. But that doesn't mean that I'm not continuing any of the other things that I'm doing. It's just, you know, it'll get done when it gets done. I gotta, you know, it takes time to do everything, but I have to get, there's only so many years you have in a life, so there's stuff that I got to do. Um, the reason I decided to get started on this while I'm still in the middle of Spivak and everything, is uh, there's, like I said, there's multiple reasons. One is that I'm teaching over the summer like I usually do, and I have a bunch of free time, that I can use to work in the library during the summer. And it's just, for example, taking Spivak's calculus with me in my bag to my job, along with all the other stuff I got to carry, is just too much. Because if you have Spivak's book, you know how heavy and sort of unwieldy it is. So I like to work on Spivak when I'm home. So what I've been doing, one of the things I've been doing is taking this book with me instead, because it's a little bit easier to carry along with me. So it gives me something to do while, while I'm at work and when I have a little bit of free time. There are some other things that I've been doing too, because there's some books that are in the library that I've been working through as well, when I want sort of a change of flavor in what I'm doing. Uh, the other reason that I'm starting on number theory is on the channel. Is because of my summer reading that I've been doing. So if you've been following along, I've been reading a bunch of biographies that have to do with famous important mathematicians at the turn of the 20th century, like Andre Weil and David Hilbert and Felix Klein and Richard Courant and a bunch of other people, Artin and so on. Uh, and I want to actually brush up on some of my stuff that I need in order to actually read some of their actual works, a lot of which have to, do with number theory and analysis and so on, group theory and that kind of thing. So that's why I wanted to start on this so that, uh, you know, eventually, hopefully not too far down the line, I'll be able to actually read through their famous works and at least understand some of it. So that's one of the reasons I have. So in order to do this, and you'll see why, because I'm going to read you guys the introduction to this book in a second. I have to. That means that I have to start a playlist on number theory. We'll start with elementary number theory, which is mainly what this book is on. I have to start a playlist on algebra, both linear and abstract. So, we have to know about groups, we got to know about rings, we got to know about vector spaces, and so on. So I won't talk about those things here, because I want this video just to be about Niven's book. Um, I also have Niven also has two other books that he wrote that I have, but I'll talk about those another time. Um, Mainly, I want to be able to read. The main goal is for me to be able to read uh, Hilbert's Zauberricht. That's kind of the thing that spurred this idea along, which I talked about in one of my previous vlogs. So you could check that out if you want to know about that. Um, so yeah, so I'm gonna have to start some linear algebra, some. I already started linear algebra done right, but I put that on hold because I've been focusing on Spivak. But like I said, I don't want to get too off base here. I'll talk about that other stuff when I start those playlists. But we'll have a we'll get back into linear and some abstract algebra, and we're gonna have to do some analysis, complex analysis, and so on. So, like I said, that'll be on the docket for the future. Um, I'm gonna try. I still haven't even begun on the exercise set for Chapter 11 in Spivak, but I think maybe I'll try and do that next weekend, maybe. Like I said, it's hard for me to bring that book with me to work because of how unwieldy it is. So I'll have to work on that on the weekends. But, during the week while I'm at work, I can do this and so on. So I already finished section 1.1 here, which I'm going to post. Actually, maybe I'll do it in this video. Why post a separate one? Or actually, you know what? Because I'm going to read you the introduction. That might be kind of long. Maybe I'll break them up into two videos. So I'll do my summary for section 1.1 in a separate video. Um, and then I'll talk about the other books that I'm gonna be doing when I get around to that. Um, so I guess that there's really not much more to say there. Let me read the introduction to this book or the preface, and then right after this, I'll record the video on section 1.1. All right, so where's my glasses? Here's the preface. This text is intended for use in a first course in number theory at the upper undergraduate or beginning graduate level. To make the book appropriate for a wide audience, we have included large collections of problems of varying difficulty. Some effort has been devoted to make the first chapters less demanding. In general, the chapters become gradually more challenging. Similarly, sections within a given chapter are progressively more difficult, and the material within a given section likewise. At each juncture, the instructor must decide how deeply to pursue a particular topic before moving ahead to a new subject. It is assumed that the reader has a command of material covered in standard courses on linear algebra and on advanced calculus. We're in the middle of doing our advanced calculus stuff with Spivak and Tau. Uh, but and I started on linear algebra done right, but like I said, we'll have a separate video for that. Anyway, um, where was I? Lost my place. And on advanced calculus, although in the early chapters these prerequisites are only slightly used. A modest course requiring only freshman mathematics could be constructed by covering sections 1.1, 1.2, 1.3, um, 1.4 through theorem 1.21, 21, 22, 23, 24, et cetera, et cetera. I won't go through the list, but you can make an element. What he's saying is you can make a easier course by restricting yourself to certain sections. The instructor may wish to obtain from the public. Then he's talking about solution manuals and stuff, which I don't have, unfortunately. But this book, I think it has solutions to odd numbered problems maybe in the back, or maybe just to selected problems. Uh, yeah, it's not full solutions. It's hints to selected problems in the back. So it's not very much at all. It's only a few pages of hints. Anyway, let me see. Where was I? Where did I leave off? New in this edition are accounts of the binomial theorem, public key cryptography, the singular situation in Hensel's lemma, simultaneous systems of linear Diophantine equations, rational points on curves, elliptic curves, description of Falting's theorem, the geometry of numbers, Merton's estimates of prime number sums, Dirichlet series, and asymptotic estimates of arithmetic functions. Many other parts of the book have also been extensively revised, and many new starred problems have been introduced. We address a number of calculational issues, et cetera, et cetera. In the appendices, we provide some important material that all too often is lost in the cracks of the undergraduate curriculum. Let me just real quick take a look and see what's in the appendices. So the appendices, they have the fundamental theorem of algebra. That's A1. A2 is symmetric functions. Oh, that's interesting because that applies to Galois theory. So maybe I'll take a look at that. I don't know, somewhat in the beginning, maybe. A3 is a special value of the Riemann zeta function, and A4 is linear recurrences. Yeah, and it has a bunch of references too. So maybe I'll take a look at the references for you guys in this video too. Number theory is a broad subject with many strong connections with other branches of mathematics. Our desires to present a balanced view of the area. Each subspecialty possesses a personality uniquely its own, which we have sought to portray accurately. Although much may be learned by exploring the extent to which advanced theorems may be proved using only elementary techniques, we believe that many such arguments fail to convey the spirit of current research and thus are of less value to the beginner who wants to develop a feel for the subject. In an effort to optimize the instructional value of the text, we sometimes avoid the shortest known proof of a result in favor of a longer proof that offers greater insights. And then there's just the authors thank, people that helped with the book. Okay, so that's the introduction to the book. Like I said, it's an introduction to the theory of numbers by Niven, Zuckerman, Montgomery. Before I let you go, let me actually read out the general references in the back so you can see the references are actually involve some non-trivial books, some of which I have, a lot of which I don't. But anyway, we'll go through the list here. It's not that long. I think it's like 2 or 3 pages. So let's see. He has The Theory of Partitions by Andrews, Introduction to Analytic Number Theory by Apostol, which I have, and I plan on going through that book after this one. Transcendental Number Theory by Baker, Number Theory by Borovich and Shafarevich, uh, Bressoud's Factorization and Primality Testing. I have that book. Haven't read it, but I have it. Castle's An Introduction to Diophantine Approximation, um, An Introduction to the Geometry of Numbers. Cassels has a lot of references here. Rational Quadratic Forms by Cassels. Uh, Chahal, Topics in Number Theory. Davenport, The Higher Arithmetic. Another by Davenport, Multiplicative Number Theory. Dixon's History of the Theory of Numbers, which I've looked into picking up. I've decided that I'm not going to because um, some of them are kind of expensive, and it's basically just there's 3 volumes, but they're basically just an encyclopedia of important number theory theorems and so on. And I don't know that that's something that I particularly need to have. Maybe that will change in the future. I don't know. But anyway, I don't have that Dixon's History of Number Theory of Numbers yet. Fulton, Algebraic Curves, An Introduction to Algebraic Geometry. Gauss's Disquisitioni Arithmeticae, which, funny story, actually. I've tried to pick up an English translation of Gauss's number theory book 2 or 3 times now, and every single time I've purchased one and it was on the way to be delivered. Something happened on delivery where I wasn't able to get the book, which I just happened yet again. I ordered the book, the English translation of it, and I don't know if it's like the tariff stuff that's going on. I know a lot of like shipping chips had like long wait lists to to come into port and offload their stuff. I don't know what happened, but I had to get a refund because it wasn't coming. So I don't know. It's like cursed or something. I can't get my hands on a copy of Gauss's book. I'd like to at some point in the future, but who knows? Anyway, um, Representations of Integers as Sums of Squares by Grosswald. Geometry of Numbers by Gruber, Lecker, Kirker. Sequences by Halberstam and Roth. An Introduction to the Theory of Numbers by Hardy and Wright, which I do have. Topics in Algebra, I do have, which brings up another point. In order to go through this sort of um, project, I guess, if you want to call it that, in addition to some other number theory books, I'm going to need to do, like I said, analysis. I'm going to have to do complex analysis. I'm going to have to do algebra and both abstract and linear. So, but anyway, Herstein is a book on abstract algebra, which I have. Um, And I've actually worked through because I used that book as a supplement when I took abstract algebra as an undergraduate. Anyway, Introduction to Number Theory by Hua, Elliptic Curves by Huesmiller, Classical Introduction to Modern Number Theory by Arland and Rosen, which I have, but that's a graduate level book. So probably won't be going through that one, not, at least not anytime soon, but I do plan on going through that book eventually. The Arithmetic Theory of Quadratic Forms by Jones, Continued Fractions by Kinchin, The Art of Computer Programming by Knuth. If you've seen previous videos, you know I actually own the all of the volumes of that. Koblitz, A Course in Number Theory and Cryptography, and another book by Koblitz, Introduction to Elliptic Curves and Modular Forms, both of which I want to go through. Koblitz also has a book on p-adic analysis, which I plan on doing as well. Kuipers and Niederreiter, Uniform Distributions of Sequences, Landau, Elementary Number Theory, Lemur, Guide to Tables in the Theory of Numbers, Lenstra and Tijdeman, Computational Methods in Number Theory, Levesque, Fundamentals of Number Theory. There's a few books by Levesque, actually, Reviews in Number Theory, Studies in Number Theory, Topics in Number Theory. Mordell, if you know about the Mordell conjectures, those are some important theorems in number theory. Diophantine equations, Nagel, in Introduction to Number Theory, which is a pretty famous book. I don't have it though. Integral Matrices by Newman, Irrational Numbers by Niven, which I do own. Introduction to Quadratic Forms by O'Meara. Number Theory and Its History by Ore. I do have that one. That's Dover. Actually, you can get that through Dover. The Theory of Algebraic Numbers, Pollard and Diamond. Polya and Zago, Problems and Theorems in Analysis, Volume 1, Volume 2. I don't have those, unfortunately. I would like to get some of Polya's books. So I have some of his books on problem solving, but I don't have any of his. Uh, oh, no, I do have one that he worked on with Hardy, their book on inequalities I own. Lecture notes on primality testing and factoring by Pomerantz, Rademacher, lectures in elementary number theory, undergraduate algebraic geometry by Reed. I have that one. Algebraic numbers, Ribbenboim, another book by Ribbenboim, the Book of Prime Number Records, and also 13 lectures on Fermat's last theorem. Prime Numbers and Computer Methods for Factorization by Riesel, Numbers and Ideals by Robinson, Elementary Number Theory and Its Applications by Rosen, and I guess I might as well mention that here. I will be going through this book also. I started on section 1.1, and I'll be posting my summary for this sometime this week. I'm like halfway through section 1.1. Sarah, A Course in Arithmetic. I do have that, but that's one that I'm going to do later on down the line. Solved and Unsolved Problems in Number Theory by Shanks. The Arithmetic of Elliptic Curves by Silverman. I have that. Handbook of Integer Sequences by Sloan. Algebraic Curves by Walker. And then finally, Number Theory and Approach to History by Andre Vey, which I've shown you guys my copy that I have. It's a used copy. And that's the general references for the book. So I'm going to end this video here. Oh, no, actually, there is one more thing I want to mention. This book is, I think I said at the beginning, it's kind of old-fashioned. Um, Math textbooks around this period of time in the States were written in a certain way that I don't necessarily think uh, can be used as well in mathematics education today. And the reason for that is things have gotten um, you hear about this all the time, but things have gotten a bit watered down, and the level of mathematical maturity that was expected of a mathematics student in college during this time was considerably higher than in general it is today. Obviously, that's not true for like MIT and stuff like that, but Princeton, Harvard, and so on. Um, So I don't know if you're kind of weak in your mathematics, I don't know if this is the first number theory book you want to jump into. It reminds me a bit of Rudin's Principles of Mathematical Analysis. While it's a fantastically written book, and if you read through it, you're able to work through it. You have a very nice foundation to work from. Same thing with this book on number theory. If you work through this book, you'll have a very nice foundation for number theory. But it expects a lot more of its reader than textbooks do today. So just a warning. I already have a graduate degree in mathematics, so I'm not worried about the mathematical uh, maturity thing. I know how to do proofs and so on and whatever. And I've taken courses in number theory and all these other courses as well. But if it's your first foray into number theory, I would suggest maybe starting with a different book than this one. But eventually, you might want to work your way up to this and work through the problems. You'll see as I go through it. I'll mention what I think about things as I go through it. Anyway, that's the last thing I'll say about this book for this video, but I'm going to post right after this my summary for section 1.1. So I'll see you guys in that video momentarily.